Hello, this is a video to help on the Analyzing Data Sets worksheet. These first problems are pretty self-explanatory. You will just have to plug in these data sets into stats.blue and then find your mean, median, and then your mode you'll have to find by yourself because stats.blue won't tell you that. So just type each of these in, you'll get your information. You could also choose to solve by hand if you'd prefer to do that on each of those three. That's fine. For number 5, you'll do the same thing. You'll plug in these data sets or solve by hand, find your mean, your median, and your mode. You'll be asked to find what percentile the student who is scored an 89, what percentile they are in. On a previous video, we talked about percentiles, so you could go back and watch that. We are going to draw a box and whisker plot, so this uses our 5-number summary that stats.blue tells us. So that's our minimum, our Q1, our median, our Q3, and our maximum. And then if you see any outliers, these are numbers that aren't within your data set, they make the data skewed, then you can explain there. There might not be either. And then these last 4 data sets, I would definitely plug into stats.blue and find your mean, your standard deviation, and your variance. You will have to do a little bit of math to find the variance. Your mean and your standard deviation will be given to you. What I really wanted to look at was this puzzle called The Usual Suspects. So on March 14th of last year, a shocking crime was committed. An evil individual set out to crumble the very foundation of Mathtropolis. The villain stated that pi is equal to 3.14. Unfortunately, the Mathtropolis Police Department has 10 suspects in custody, and they are sure one of them is the culprit. So we are going to help the police department determine which of the suspects is guilty. The table shows the suspects responses to a series of questions whose population, mean, and standard deviation are given below. So they give us instructions, we have these questions, we have standard deviation, we have mean for each of them. We also have the different suspects listed out here, and then their answers to these 6 questions. So the first one, we are going to begin by identifying the 5 suspects whose responses to question 1 are more than 1.5 standard deviations from the mean. So we're going to look at just question 1. We need to figure out what 1.5 times our standard deviation is. So 6 times 1.5. And we get that this is 9. So to figure out if the suspects' answers are more than 1.5 away from the mean, we're just going to do 17 plus 9 and 17 minus 9 to figure this out. So we have that 17 plus 9 is 26 and 17 minus 9 is 8. So any suspect that has a smaller answer than 8, like B, and a bigger answer than 26, like D, are still suspects, actually. I didn't want to cancel them out. I wanted to circle them. Okay? If they're within the range, they are no longer suspects. So 9 is between 8 and 26. 5 is not. 25 is. 22 is. 27 is not. So we have 5 suspects left. B, D, E, G, and J. So then, of these 5, identify the suspects whose responses to 2 and 3 are both more than these 1.7 standard deviations from the mean. So 2 and 3, they give us our standard deviations. We need to find what 1.7 of that is. So for this one, we have 2.21. You'll have to take 5.1 plus 2.21 and 5.1 minus 2.21. And we get 2.8. 5.9, and 7.31. We'll do the same thing over here for question 3. I'm going to leave it as decimals. You could also probably switch it over to, or I'm going to leave it as percent, 9.5. You could probably also switch it to decimals. But either way will be fine. You just have to do a lot more converting that way. So 1.7 times our standard deviation is 16.15. So if I add and subtract, we end up getting 67.05 and 99.35. So we need to look at our remaining 5 suspects. I'm going to cross out the rest of these because they are no longer suspects. And they need to both be larger or smaller than these numbers. So suspect 2, we have 9 on question 2. That is bigger than our range here. But 96 is within this range. So suspect B, no longer a suspect. Suspect D, we've got 8, that is bigger again, and 66 is smaller. So suspect D, still a suspect. These both make him a suspect. Suspect E, 5 is within this range, so he is no longer a suspect. 59 is with outside, but both of them needed to be outside. G, 2 is smaller than 2.89, and 100 is larger, so he is still a suspect. And then we need to look at the last one as well. 1 is also smaller, and 60 is smaller, so suspect J is still a suspect. Okay, and then for these last ones, we are going to, of these 3, identify the suspect whose responses to 4, 5, and 6 are all at least 2 standard deviations from the mean. So we're going to take our standard deviations and multiply by 2, and then add and subtract those from our mean. And then whatever, is outside of that will still be a suspect, or we'll find our actual criminal. Okay, so our range here, we're looking for them to be between 4.9 and 15.7. For here, we're looking for them to be between 2.3 and 5.5. And for here, we're looking for them to be between 3 and 7.4. So this first one, (16) is not between this range. 2 is not between this range. 7 is between this range, which means he is no longer a suspect. We're looking for them all to be outside. Suspect G, 4 is not in this range. 6 is not in this range. 3 is one of the edges of the range. But those are not included. So right now we're thinking that suspect G is our criminal. We'll check J just to be safe. So J, 18, not in this range. 5 is in this range. 3 in the range but not included since it's our lower bound. So this is okay because this 5 is within the range. So J is not a criminal, which means suspect G is our criminal. hopefully that helped you kind of understand standard deviation a little more and how you can find how far away from the mean it is given a certain standard deviation. You could also have 3 standard deviations from the mean and find something there as well.